has an inequality sign. Welcome back to Algebra 2. Today we are doing 2.8, two-variable inequalities. So our objective is to graph two-variable inequalities. And by two-variable, x and y. So we're graphing inequalities. So let's get started. If you recall, no, just kidding. From Algebra 1, you kind of talked about this, so hopefully this is a kind of a review from Algebra 1. And if not, that's okay. We're going to learn some inequality graphings today. So, linear inequalities, we have this. So instead of on a number line and open or close and we shade to the left, shade to the right, now we graph and we either have a dashed line or a solid line. And then, so this is called the boundary. So the boundary is, where your line is. And then the shading, we either shade above the graph or below the graph. And that would be your half plane of all of these coordinate points. So like right here, this coordinate point of 1, 2, 3, 1, 2, 3. So 3, 3. It works for whatever this equation is. It satisfies that equation. If it's on the line and it's dashed, it does not work. But if it's on the line and it's solid, it does work. It does count. So like all of these are solutions for this inequality. Any of those, even like if it's in the middle and not even on a dot, okay? There's an infinite number of possible solutions. So let's talk about dashed versus solid and the shading. So we have dashed line. So if it's a less than or a greater than, it's a dashed line. Okay, if it's a less than, then we shade below. And then if it's a greater than symbol, we shade above. And that kind of makes sense, right? If something is greater than, it's like above it, more than. If it is less than, then it's below and beneath it, okay? If it has a line under it, which is like half of an equal sign, that means that it's a solid line. That means all of the points that are on that line are also included, okay? Same with this. If it's a less than or equal to, it's shaded below. So shade below. And then if it's a greater than or equal to, we shade above. Okay, so like if this inequality, I can tell since it's a dashed line, it's going to be a less than. And then if it's shaded, since it's a dashed line, it's just going to be one of these, a greater than or less than. And because it's above, it is a greater than. And then for this one, it's a solid line, so it has one of these. And it's below, so this would be less than or equal to. Okay? And I mean, we could even go as far as to pick the slope and the y-intercept, but we'll talk about that in a second. So let's talk about actually physically graphing these. And so that's what we're gonna do for the next 3 problems, is just graphing these. So first thing that we always have to do is it always has to be in the y equals, whatever your inequality is, that's what your equals, mx plus b. Okay, so since it's inequalities, there's not gonna be an equal sign there, there's gonna be an inequality sign. So our equation is y is greater than 3x minus 1. Okay, so we're going to graph this like a normal line, slope and y-intercept. Okay, this is your slope, your m, 3 over 1. This is your y-intercept, your b, your starting point. So I'm going to try to make this as neat and as pretty as possible. So if we have our graph, we always start with our y-intercept at -1. So right down here. Our slope is 3 over 1, so that means we go up or down. And always go up or down first, preferably up. Think about like if you have to go to a chair, you have to get up and then move. So if you go up 1, 2, 3, then you go over +1, since 3a is a positive number. Or you could go down 1, 1, 2, 3, over to the left 1. Oh, just kidding. I messed up. And why did I mess up? Because I just drew a solid line. However, we have to look at that inequality. I was just graphing a line to graph a line. However, that graph is wrong. So let me draw that graph again. Okay, so still, our y-intercept is -1, up 1, 2, 3 over 1, down 1, 2, 3 to the left 1. Okay, so before I just automatically draw a line, we have to look at your inequality. Okay, there is no line under there. It's just a greater than symbol. So that means that the points on this line are not included. So instead of drawing a line, I have to do a dashed line. Okay. Now, so that's dashed. Now we need to shade it. So we have to figure out shading above or below. So this says y, all the y values are greater than our line. Greater than means above. And so we are going to shade above towards the top arrow, because sometimes, like, it depends, like if it's a super steep line, it's gonna be hard to tell what is above and what is below. So I always tell my students, look towards, shade towards the up arrow on your y-axis, and wherever that falls, that's where you shade. Okay, so that's what you do. So all of these coordinate points they satisfy this inequality. Okay, let's do another one. And I'll not just graph it, I'll take my time this time. So we have our graph. Okay, so we need to, our inequality is less than or equal to. So I'm going to start with our M and B, label those. So our starting point of our graph is -1. So we go down to -1. And then what? It's same. Our slope is 3. So up 1, 2, 3 over 1. 1, 2, 3 over to the left 1. Okay. So we look at our inequality. It has a line underneath. So that means it's going to be a solid line. That means it's an equal sign. All of these points are included. Very poor line, but that's okay. You guys get the idea. And then it's a less than. Less than or equal to means it's below, it's beneath. And so since it's that, we are going to shade towards the bottom arrow of our y-axis. And it doesn't just stop here, like it goes on forever here, forever there, forever over there, forever down here. It goes down to infinity. All of these coordinate points that fall below are included in this inequality. Okay, now let's talk about an absolute value inequality. Same thing, except we're gonna be kind of double thing. The y, we still need to get y equals mx plus b form, but in this, it's y equals absolute value form. The absolute value, like the a, absolute value x minus h plus k form. So remember, absolute value graphs are v-shaped. Okay, so this isn't gonna be a line. It's okay, we're professionals. So first, this does not, our y is not isolated. So our first step is to isolate y, and by that I mean just get y on the side by itself. Okay, so think of this as your imaginary fence still, it's at your inequality. This one, we need to subtract to move it to this side. Cancel, cancel. So bring down -y is less than absolute value of x plus 2, absolute value, and then our -1. This cannot go in the inside of the absolute value. It goes on the end. Those are two separate terms. We can't combine them. So now we're almost there. We have a -y is less than this absolute value, but we need a positive y. So this is like an invisible -1. We divide by -1, and we divide this whole side by a -1. Okay, so two things. That's gone. So we have our y. Anytime, I'm going to go over here in red, put this in your notes. If you multiply or divide by a negative number, like we just did, we divided by a -1, we have to flip the inequality. That's inequality. Okay, there you go. It was a less than. Now, since we divided by this -1, it becomes a greater than. Okay, and so we have two parts of this. We have our absolute value part, and we have our -1 part. So what we need to do is we need to divide this by the -1 and this by the -1. So this divided by -1 would just be a -1 out front, right? 1 divided by -1 is -1. So -1, absolute value of x plus 2, okay? This tells me it's gonna be reflected across the x-axis. Hopefully that kind of rings a bell like, oh, it's now a -a. Now we're gonna talk about -1 divided by -1 would be a +1. Okay, so now we are going to graph. We are writing a graph. It's a V shape. So we have our graph. I'm going to talk about, let's find our, first let's figure out with our A, what shape is this? Okay, so since it's a -1, it's going to be an upside down V. Okay, this inequality makes it a dashed upside down V. So I'm going to do just a little. It's gonna look roughly like that. Okay, now let's talk about what our vertex is. Okay, vertex, our coordinate point, we drop our 2, switch the sign. So it's a +2 here, it's a -2 here, and this is a +1. Okay, our axis of symmetry is x equals -2. And then let's go ahead and graph, and we'll talk about max, or we know it should be a maximum and it should be 1, but let's just graph it. So let me put my, okay, so our vertex is -2, +1, which is right here. Okay, our kind of slope is down 1 over 1. So down 1 over 1 here, it's reflected over there. Okay, and that should be good. So we're gonna draw our line, but before we just draw it, we need to make sure it's a dashed line. Okay, so our graph is drawn. Now we need to check the shading. Okay, so our inequality is a greater than. So all the y values are greater than. So what we're gonna do, we're gonna shade to the up arrow. So that's all of this over here plus over here. So everything above this inequality is shaded. Okay, that was a lot. That was a big problem. I think you'll be great. Let me know if you have any questions. I think that's it for this lesson. So lesson 2.8 Math XL. There are 9 total questions. Reach out to me if you have any issues or questions on the assignment. Bye.